Hi everyone, in this video I'm going to be looking at how to perform regression and prediction using scikit-learn in Python. Both my response and feature variables are numeric, so let's get started. In this exercise, I'm curious to find out how to perform regression prediction using scikit-learn in Python, so I'm going to ask ChatGPT that. Let's see what it says. So it's pretty good. It gave me a general workflow of what I need to do to use scikit-learn for regression prediction, starting from the packages that I need to import, how do I prepare my data in arrays, how do I split my training and testing data sets, how do I fit the model and predict it, and then finally evaluate the model's performance using mean squared error. So this is great, so I'm now going to move on to my Jupyter Lab notebook. All right, let's start with importing the relevant packages. And then for this exercise, I'm going to be using the wine data again. So what I like to see is if I'm going to be getting the same results comparing the stats model and scikit-learn method. Let's read in our first wine data set and then have a look at the first 10 lines. And then let's also read in the second wine data set and have a look at the first 10 lines to inspect it. So similarly, I'm going to be looking at taking away the missing values in wine data set 1. So as we can see here, there are 13,000 missing values in price, and I'm going to remove that using drop NA, and I'm also going to drop the missing values in country and province as well. So let's run this real quick. And now we can see that both price and points are without any missing values. So for scikit-learn to work, we need to do a little bit of data preparation. It requires both response and feature in distinct variables x and y, and each of the variables need to be in arrays with compatible shapes. So let's then create the array, and let's see the type. So that's good. We confirm that it's an array. And then let's just quickly have a look at the shape. As we can see here, both x and y are one-dimensional array. So it's okay for y to be a one-dimensional array, but for the x variable, it has to be formatted as a two-dimensional array to be accepted by scikit-learn. So we have to convert the shape of x by applying the dot reshape method and passing in -1 followed by 1. So let's run that. And so now we can see that the shape is two-dimensional. So I want to quickly plot a scatter plot to have a look. So there we go. We have the scatter plot that we've seen before in my previous video. So next we're going to be working on fitting the model, and we'll import linear regression from Askchatgpt linear model. And we create an instance for linear regression. And here we're going to use model.fit to fit the x and y variables. To analyze the coefficients and intercept of the fitted model, we run the coef underscore and intercept underscore command. As we can see here, the slope is 5.18 and the intercept is -422, and the results matches the one that we got using stats model. And so this is the equation right here. So what this means is for every point increase, we will get a $5.18 increase in price. So now that we have the model in hand, what I like to do is to use this model to predict price based on the points in the second wine dataset. So I'm going to check wine 2 dataset for missing values. So true enough, we have about 8,000 missing values in price. And so I'm gonna drop the missing values using drop NA in price as well as these other variables. So let's do that. So now we can see that both price and points has no more missing values. So similar as before, we want to make sure that both our response and feature variables are in array. So let's do that and make sure that that's the case. So next we want to make sure that the x variable is in two-dimensional array. So indeed it is, and our y variable is in one-dimensional array. Next, we're going to use the model to predict the prices for points in the second wine data set. So let's do that, and let's do a plot scatter of the original price and the predicted price for the second wine data set. So the plot looks great, and now I want to move on to evaluate the model performance. So for that, I'm going to import mean square error from sklearnmetrics. But first, I want to calculate the r-squared value. So for that, I'll use the score command on the model. So recall that r-squared is the proportion of the variance in the response variable that is predictable from the explanatory variable. So we got an r-squared value of 0.211, which is similar to what we got using stats model. What this means is about 22% of variance in price is explained by points. Next, I'd like to calculate the residual standard error. So residual standard error is the measure of the typical size of the residuals and how much the predictions are typically wrong. So for that, we're going to use the mean squared error and setting square to false. Here we got a value of 37.3. So what this means is the difference between the predicted value of price and the actual price is typically around $37. So the model has an average error for price of around $37 per point. And this is close to what we have calculated in my previous video as well. So that's all I have for this video. I'm able to confirm that the results are the same using both stats model and scikit-learn on performing regression prediction on numeric variables using the wine dataset. I hope that you can try this out yourself, and I'm going to put a link to my JupyterLab notebook underneath the video. Until next time, bye.